Jack from Gamewagon here. Today I'm going to take you through a very, very classic game, possibly one of the first games ever available. Pong is a simple version of table tennis, very recognisable to everyone, and a great two-player game, so you can enjoy it with a friend as well. We're going to start this game from a blank or a template that junior game creators uses quite often. If you search on Scratch for JGC blank and then click on the Studios tab, you'll find dozens of fantastic template games with the sprites and the assets already in there where you can fill in the code yourself. So it's just giving you a little jump start to get used to the coding, get used to making the games, and then from there you can completely change the artwork and the assets and how the game looks. I think it's a good way to learn how to make your own games and a great way to get started quickly without having to get bogged down in graphics and art if that's not really your thing. So we're going to start like we always do with a game engine sprite. I've created a blank sprite from this button over here, and we're going to fill in some code that's going to help us get the game set up and going. So we're going to start with a when green flag click button. And this is going to be the only one we use in the game. This is a technique we use at junior game creators quite a lot. It just helps Scratch run more smoothly. So this will be the only time we see the when green flag click button. And from there, we're going to go straight into a broadcast. So this is going to send out the message for a new game. And we're going to call this message new game. So now whenever the green flag's clicked, it's sending a message to all our other sprites to say broadcast new game. Now we want to keep score here, so let's go into our data, and for scores, health, any kind of numbers you want to keep track of, we're going to use a variable. So we're going to make two scores because we've got two players. We've got P1 score, and we're going to have P2 score. Now forever, if our scores are equal to 5, we want the game to finish, because any player that gets to 5, first to 5 points wins. So the game's going to be over when a player gets to 5. So player 1 score is 5, and player 2 score we want equal to 5 as well. So let's just build those blocks. But instead of making two different if statements for this, we can combine them into one using a very handy operator called OR. So it's only going to complete the action below if either of these scores are equal to 5. So you get 1 point for a one point for a point, 1 point for a score, 5 of those and you win the game. So when that's happened, we're going to stop everything. Now at this point, you could use a message to broadcast to other sprites to run some kind of game over state. So maybe you want a button to appear with a rematch on it, or maybe you want fireworks for the winner. Maybe you want to do some cool graphical effects. It's entirely up to you. But for now, we're just going to stop everything. And if you see in our instructions here on the background, we're going to have when you're ready, you've got to hit the space bar. So this is our initialization, we call it. This is going to initialize our game. It resets everything back to the start. But we're going to use when the space key is pressed. We're going to set our scores back to 0. And we're going to broadcast reset as well. So reset is going to put everything back to the beginning without necessarily causing the whole game to start over. So reset the game is a quick way for players to play a rematch if they want to. So that's our game engine done. Make sure everything's nice and tight. That's going to be controlling the flow of the game. So click the green flag, check for scores, click the space bar, reset the game. So if I hit the space, nothing's happening yet, but that message will be working. Now, I've got these variable holders over here. These are going to tell us a thing. And something I quite like to do with a game like this where you need to see a lot of the screen. If you right click on the variable readout and hit large readout, you get just a number, which is why I've made these little containers for them on the backdrop here. So we've got player 1 score over here and player 2 score here. Just check I've got the right way around. I have. Drop those into position. So now we've got player 1 versus player 2. So our code for player 1 and player 2, the paddles that you control, are going to be very similar. So we'll work on player 1, copy and paste it over to player 2 and just make some adjustments for positions and numbers. So for player 1, first thing we want when you get new game, let's make sure everything starts back to the start. So when I receive new game, let's set the rotation style to all around. Because if you notice here, our costume is facing side on. And rather than go in here and twist it on the costume editor and a little inaccurate, we're going to use some code to make it stand upright. So we're going to point in direction 0, which if you'll see from here is straight up. And then we want it to get into position over here. Now the Y position is going to change with our buttons, but the X position is never going to change. You're never going to come forwards or backwards. So we want to go to -200 for X, and Y is going to be 0. So plug those numbers in. Now if I hit the green flag, we should get the sprite over here, which it already is. Now when I receive reset, so this is when the game is starting, we want to make sure we're in position again, because your game may have ended up over here. Make sure both players start from a fair position. And then we need to put in some stuff for our control. So because we want our buttons to always work on our paddle, we need to use a forever block. We don't want them to go flying off the end of the screen, so we're going to use an if on edge bounce. And then we need 2 if statements, one for up and one for down. So player 1's going to be using the W key and the S key. If you play any computer games, PC games, you'll be familiar with using W, A, S and D to control a character. We're going to utilize that feature here. So we need a sensing block if key W is pressed. And we need an S one if S key is pressed. Now we want to change our Y coordinates, just up and down, no X's. So we're going to change Y by 10 to go up and -10 to go down. Excellent. So if we test that out, nothing's going to happen until we hit spacebar to say we're ready. And then I can move my paddle up and down. It won't go off the ends. And hitting spacebar again is going to reset it back to the center. Now, essentially, we want the same lumps of code for our player 2. We just want to make sure some of these numbers and buttons are the other way around. So right click, duplicate, drop it on player 2. Right click, duplicate, drop it on player 2. And we're going to spread these out a bit so we can see what we're doing. So over here, we want our paddle to be far over on the right, but we want it to be the same distance from the back so that it's fair. So we're just going to use 200 instead of -200 on the X coordinates. Still got the same all-round rotation style, still pointing straight up. And when I receive reset over here, we want it to go back over to the right, otherwise we're going to end up on the left side of the screen. And we're going to use the up and down arrow keys for this player. That way you've got a bit of room on the keyboard. Still changing Y by the same amount. So let's have a look, see if that works. Green flag, nothing happening yet. Hit the spacebar and we can move up and down, up and down. I'm playing both players at once here because I'm on my own. Hit the spacebar, reset to the center. Brilliant. So our players can move, our paddles can move up and down, but tennis is nothing without the ball. So let's go over to our ball sprite, and this is where things start to get a little bit tricky. We need a fair bit of code in here to make sure our ball behaves the way we expect it to, but that also introduces a little bit of randomness. One really important thing to bear in mind here is the original Pong game, and even real life tennis and real table tennis, actually follows quite a complicated set of mathematical equations. So if the ball was coming down here, bouncing up, and then bouncing off of here, bouncing down here again, it would be fairly simple. But because our paddles are moving, you would expect the ball to move perhaps in the direction of the paddle, perhaps at a slightly sharper angle if you're moving faster. These are all quite complicated mathematics that unfortunately Scratch just isn't quite able to handle. So we can get a pretty close approximation by introducing some random numbers. So straight off bouncing in the same angle every time would be incredibly boring for the players. Very, very realistic simulation for the physics is too much for Scratch to handle, so we find a middle ground by using some random numbers. Very useful in game design. It can give the illusion of realness or reality. So we're going to start off with our new game broadcast up here. When I receive new game, we don't want to see the ball right away. We're only going to have it appear when the game starts, so we're going to hide it. And again, we're going to set the rotation style to all around because we're going to be controlling the ball with its direction, the direction in which it's pointing. We're not just going to be changing its coordinates, we're going to be moving it around in a direction. So set direction style to all around. Now, what happens when the game starts? When the game starts, we're going to need the ball to appear. So our reset broadcast. First of all, let's just plop in a bit of code to tell the ball how to behave and where to go and when. So when I receive reset, let's start in the center. Seems like a good place as any to start. So we're going to have it go to 0, 0. We want to see the ball, so we're going to show it. And then we want to control its movement. That's its movement around the screen, its movement off the walls, its movement off the players. So we're going to do a massive forever block here. This is going to be stretched out enormously. And inside that, we need 3 if statements. So we want one for the start of the game, one for if it's hitting the paddles, and one for if it's hitting the other paddle. So we're always going to have it bouncing off the edges. Fortunately, this is a bit of complicated maths that Scratch includes for us. If we didn't have the if on edge bounce button, we would have to work out the maths for ourselves. And we're always going to have the ball moving at the same speed. That's 5 steps per refresh. So we've got 5 steps. Now, the first thing we want to do is control whether or not the ball is going to go left or going to go to the right when we kick off. If it always went to the right, it would be a bit boring and might feel a little bit unfair for player 2. If it always went to the left, same thing, it might feel a bit unfair. So we're going to include a little bit of code here as well on our reset with an if statement, and we're not going to put a forever on this one because we only want to check it when the game starts, and we're going to use an if else. So if player 1 score is greater than the player 2 score, that is to say if player 1 has got more points, then we're going to point in a direction that's facing to the left. So that way player 2 gets a little bit of an advantage if they're behind. So we'll point in direction left. But if it was just to go dead straight left, that would be kind of boring and kind of easy for player 1. So we're going to use our random numbers here. And we're going to use an arc that's roughly 90 degrees, or exactly 90 degrees, sorry, but roughly covers this whole side. So it could go anywhere from here to here. So we want to go minus 45, which is this kind of direction, all the way to minus 135, which is this kind of direction. So the ball's going to end up anywhere over here. And we want to do the same if player 1 isn't in the lead, which will cover both bases for if it's a draw or if it's player 2 in the lead. But this time we want it to go left, so we're not doing minus numbers, we're doing positive. So 45 degrees roughly over here, because remember 0's at the top, and 135 roughly down here. So now we know that when the game starts, each time a point is begun, then it's going to go to a good position. Now, when I receive reset, we want to go back to the start. If we're on the edge, we want to bounce, we want to move 10 steps. So what happens if we hit the paddles? Now, if it's touching player 1 or player 2, so we're going to use our player block again, our or block, sorry, and a couple of these sprite touching buttons, player 1 or player 2. It's essentially going to do the same thing, point in opposite direction. All we need to do is add 180 degrees to it. So the direction that it's already moving plus 180 degrees, that just turns it round. So we're going to take an operator here, drop that in. We want the direction of the ball. Now this is a super useful block actually. Pay attention to this, it's at the bottom of the sensing tab. And this gives you all kinds of data about all of the different sprites in the game. So if you want to use the position, the direction, the costume number, the size, the volume of certain sounds of any of your sprites. You can use that in equations to create different systems. So we're going to be using direction of ball, and we're going to add to that 180 degrees. That means if it's going to go straight across here, it's just going to turn around and go straight back. But that does mean if it hits over here, it's going to go straight back, and it's going to keep going backwards and forwards in a straight line. A little bit boring, so we're going to add in some of that randomness I spoke about earlier. And instead of adding exactly 180 degrees, let's add somewhere between 160 degrees and 200 degrees. So that's an extra sort of 20 degrees in either direction. It's going to give us a slightly wider scope of where the ball can go, and introduce a little bit of randomness to the game. Let's just test this out for now and see what happens. So ball's hidden, hit space when we're ready, off our ball goes, it's bouncing off our paddles, not too fast, not too obvious where it's going to go either. Now it could be when you come to play you really want to speed this ball up. It's as simple as changing this number here in our move steps button. Brilliant. But what happens if I miss? Nothing so far. So we need to include two if statements to decide what happens if the ball goes out of bounds and the player scores a point. One for player 1 and one for player 2. And we're going to do that by measuring the x positions of the ball. So a little bit more mathematics here. We're going to take some less than blocks. Now less than are really useful. Scratch doesn't always update numbers as quickly as you want it to, so using an equals block, even though it should in theory be perfectly valid to equal a distance greater than the paddle, Scratch can't always detect it at the right time. So using a greater than or less than block is super useful in this case, because it means we can say if it goes past it, just bring it back, all right? Or if it goes past it, trigger this. So we're going to use our less than block in here, and we want to know if the x position of our ball, that is the left and right position of our ball, is less than the x position of player 1. So if it's this side of our player, x position of player 1, then we want to change the score for player 2 by 1. We'll wait a second just so both parties know what's happened, that a point has been scored, and then we're going to broadcast our reset, which is going to send everything back to the start. Now remember, reset doesn't reset the scores, it just resets the positions of everything. You need to click the green flag to restart everything. So it's useful in this case for being both the start of the game and the start of each point. So let's just check that out, see if that works. I've got a feeling it's not going to be exactly what we need. I'm going to purposely miss this as player 1. It stopped right there, right in line with where the player 1 paddle is, which isn't ideal because I feel like I could probably still get to that. You don't want the player to ever feel like they're being cheated by the game. So we're going to add some extra x coordinates to this this measurement here, just to make sure it really goes past it. So I'm going to take this block out, and I'm going to add a plus block in, an addition block. So if it goes past player 1 plus a few more, oh sorry, not plus, minus, because we're going to the left. So easy to get that mixed up sometimes. Even I do it from time to time. And something you always should check for if you're having bugs in your code. So x position of player 1 minus, let's try about 17. And see if that works. So it should clear it. And it stops just before it touches the back wall, which I think is pretty good. You're going to feel like there's no way you could have still got to that. Now we need to do the same thing for the right hand side, and a lot of this is going to be very similar, just with minuses instead of positive numbers. So I'm going to take this whole lump that we've got here and drop it in, but we've got a little bit of a problem because we're using less than and we've got a minus, so that's not quite going to work. Let's take this out and use a greater than, because we want to know if the x position of the ball is greater than the x position of player 1, and instead of a minus we want to use a plus. But this time we're going to be doing player 2. and it's probably going to need a little bit extra, but we'll just check and see how much. Ah, see, that's not picking up on that at all, and I suspect that's because I've left this empty hole in here. So let's add 20 just to see what that does. Just not catching it, unfortunately. Could it be that I've missed some of my code here? Fortunately, it's not picking anything up just here. So let's reduce this number. Let's take this down to 17. No reason it should be different. Ah, viewers at home, can you see what I've done here? I'm testing a little prematurely. You know, one of my golden rules is to test, test, test. I'm trying to test a lump of code here that's checking for a situation, but then not actually doing anything afterwards. So I would have been waiting a long time to see if that was going to work. So let's just fill in the rest of our code here. I'm going to duplicate this over and change some of the numbers. So we're going to change player 1 score here, wait a second and reset. So let's test it now. Hopefully we've got a little finish there. Brilliant. And our variables are going up, just as they should. And let's just double check that we get 5 points for a win. Brilliant. Game has stopped at 5 points. Player 1 is the winner. And the score's up there for everyone to see as well, so you can't cheat about it. Now, this is a super, super simple game. Very, very slow, very basic at the moment. And like I say, these blank templates are designed for you to put your own imprint on. Here, let me give you a quick example. If I was to change this to 10 and start the game, suddenly we've got a much more dynamic, much faster game that's probably going to be a little bit more interesting to play. Okay. Could be that you want to go for massive scores. So let's change it by 10,000 or 1,000. Let's do 10,000. 10,000 is pretty cool. And we're going to go back to our game engine and say if scores are equal to 100,000 or 100,000. Now you're going to have massive scores. Really, all you're doing is playing to 10 points instead, but that doesn't matter. It's just making things a bit more funky. And of course, as always, you can go in and you can change the costumes on all of our sprites. You can change the backdrop. There's no sound effects in this game at the moment. I think adding music or sound effects would be a great way to improve it. Certainly a background music or a little boop whenever you hit a paddle would be cool. There's lots of opportunities for improving this game. I can't wait to see what you guys do. Remember, head over to scratch.mit.edu, search for JGC blanks, and you'll find all of our template games, including Pong and lots more there that you can fill in the code for. Hope you've enjoyed this. Can't wait to see what you guys do with it. Thanks very much. Bye.